Ramanujan for G is now available on the Google Play Store. Try it out for free.
Hi students, so we continue with our discussion for uh, uh, current electricity. This is basically DC, direct current with batteries and circuits. Now, today, I'm going to discuss, go from simple to complicated, but generally DC is not a complicated thing, but it can be tricky. Anything can be tricky. you know so you always want to be careful there. So let me get started. And I tend to go fast sometimes, so please bear with me. you know so here is the thing. So first let me discuss the ideas around resistance. Okay, so the ease with which a charge carrier moves inside a solid when subjected to an electric field is called the mobility. Okay, and we already look at this in the context of different conductors. Each conductor will have its own mu, and mu is E tau over m. Okay, E tau over m. Therefore, E is 1.6 to the power minus 19, etc. Right? So it is specific to a particular medium, you know, and it changes with medium to medium. So here's a example. So they are giving you the sigma, which is the conductivity, right? And therefore, from the conductivity sigma, they then calculate uh, um, the corresponding mu. Okay, so the sigma is E eta mu, right? And therefore, from so mu equals n sigma over n, or E n mu sigma equals mu equals sigma over n e. E is the charge of the electron, right? Sigma is, the conductivity 5.8 to the power of 7 in the case of silicon, and n is the number of electrons, right? So in this case, they are doing copper. First case, they are doing silicon. Silicon, they have introduced a second term. In copper, there is only one term, right? In silicon, there is a second term. Now, sigma over Ne, 5.8 to the power 7. So they end up with 42 centimeter square per Vs. That is the mobility, right? So now mobility is how fast it goes, right? So now resistance is restriction to the flow of current. So resistance is what? V equals IR, right? So you keep increasing the voltage, the current will keep increasing, resistance being constant, right? But then resistance itself, the formula, rho L by A, or SL by A, where rho is the resistivity, right? You make the conductor longer, there is more resistance. You make it thicker, there is less resistance, right? So inversely proportional to the cross section, directly proportional to the length, inversely proportional to the cross section, and there is the specific resistivity. Resistivity is rho, right? So rho L by A. So now, if you have a potential difference delta V and you have the an I, therefore you end up with this, right? So now, and sigma, as you know, is the conductivity. Conductivity is 1 over resistivity, right? So keep all this in mind. Now, the other idea is that not all elements completely follow Ohm's law. Some elements, they will have not a linearity. Over a range, they may be linear, but beyond a particular range, the V versus I may have deviation from linearity. Okay, elements that show non-linearities, of course, diodes and field effect transistors, okay, FETs. Now, MOSFET, right? Then there is that is a metal oxide. semiconductor, field effect transistors, right? They all have non-linearities. They don't have a linear curve, So now there are substances which will have multiple areas. One area which is linear, another area which is non-linear, and then a third area where the resistance actually decreases. In the case of gallium arsenide, okay, I versus V. Okay, now and then there are different functions. Uh, um, like wire bond, only few ohms of resistance can be obtained. In some cases. Okay. Then finally, this color coding you should learn. Okay, so there are four bands. Okay, BB Roy, what is it? BB Roy of Great Britain has a very good wife. My God. Okay, BB Roy of Great Britain has a very good wife. Okay, very Y, right? G, good, right? So white, BB Roy, ROY, right, of Great Britain has a very good wife, right? So BB Roy of Great Britain has a very good wife. Okay. So now, what are all the colors, right? So the main ones are the first three: blue, black, and the see the black is the multiplier, you know, right? So if you had Y, V, R, and S, right? So R, the red is the multiplier, right? So Y and V, first two indicate the numbers, right? So these are all the values, right? The first bar and the second bar, right? In this case, if it was Y and uh, violet, right? That indicates the most significant and the least significant, right? So there are four. Basically, there are four: most significant, least significant, times 10 to the power of k. Okay, and then the last one is essentially it's a tolerance. So the first three only are give you the real resistance. So in this case, if you see blue, right? Blue is what? 6. Red is what? 2. 62, right? Or is this pink? Violet? Whatever it is. Okay. So if it is red, it is 62, right? So 62 into 10 to the power of 0. Okay. If it is black. 62 into 10 to the power of 0 is just 62, right? If it was the orange, the third one was orange, 62 into 10 to the power of 3, 6.2 kilohms, right? If it is red, right, they are saying 4.7 47 times 100, right? 4,700, 4.7 kilohms, right? So that's how you need to understand. You need to know which number each color represents. BB Roy of Great Britain, right, has a very good wife, lucky guy, right? So now, then the tolerances you have to see: gold, red, and no color. No color, if it's missing, it means it's 20% tolerance. Gold is the most tolerant, highest tolerance, right? So now those are the how to read a resistance. In case they ask some question, you can answer. Okay. Now, temperature dependence of resistivity, right, is a linear relationship, right? So it at T equals 0, it has some value, and for each increase in temperature from that value, right, right, you will so it is at T naught, it is a particular value. So typically T naught will be 27 degrees centigrade. So from that, it will go up a little bit, little bit for each degree, right? So how much it goes up? Rho minus rho naught, right? So now we are talking about rho, the resistivity. As temperature increases, resistivity will increase. But then one thing I'll tell you, right? if you have a wire, as temperature increases, resistivity will increase, but then the thickness will also expand in some cases. So they may include that in a question. Okay, but note the value. Rho equals rho naught into 1 plus alpha delta t. Okay, so it's the increment is a constant. Alpha is the straight line. Straight line means what? D rho by dt is a constant. D rho by dt is a constant. That constant is alpha, the temperature coefficient of resistance. Okay, so it's a straight line. Therefore, you can, using, if they gave you some values, etc., you can easily solve. Right, it's a straight line. Now there are some things that kind of straight line, but semiconductors, it is a like that. In fact, you know, copper mostly straight line, nichrome perfect straight line, semiconductors inverse line. Okay, so keep that in mind. Okay, now so another example here is he's looking at aluminum and he's discussing the mobility, etc., sigma by ne and then lambda, right? So they calculate these things very, very simply. Now as temperature increases, rho increases, sigma decreases, rho equals 1 over sigma, right? Tau decreases, lambda decreases. Okay, so rho increases, but everything else decreases. And when rho increases, R increases. This is for most conductors. Okay, including mercury. Mercury is a metal. Okay, so now the battery, when we look at battery, we talk about this thing called electromotive force. Okay, electromotive force is, or EMF, is same as the voltage of the battery, right? It's the work done on unit positive charge taking from lower potential to a higher potential. The battery is also a pump. Okay, it pumps charges from the negative, from the cathode, electrons go to the anode, but current is said to flow the opposite direction. It is a pump. Okay, now as you know, W equals EQ, right? W equals EQ, right? Therefore, from that you can derive, okay, where E is what? EMF, the voltage, okay? Voltage times charge is joules, okay? So Q times V times I is power, remember that, and I is Q over T is the rate of flow of charge, right? Therefore, work is what? Power over a period of time, right? Power is the instantaneous work, right? W by dt is power, okay? So keep that in mind. For W equals EQ, right? Where E is the voltage or electromotive force. It's the force inside a battery. Okay, so it's a now the EMF is a contour integral E dot dl. Okay, so now J is equal to sigma E. You know all this. V equals IR, right? J is a J dot A is the J dot A is the current, right? So that is the what happens if you look at the vectors inside a battery. Now, an ideal battery will have no internal resistance, but most normal batteries will have an internal resistance, which will get added to the RL, load resistance. What you get, the voltage that is listed on a battery is its open circuit voltage. So if you add a load resistance, you have to also add the internal resistance. So that is, so when you do V equals IR, you have R L, the load resistance, plus the internal resistance to be added, when you calculate the current. Okay, so that's how these things are done. Okay, so there is a potential drop from in inside the battery also. So the load will get at most a fixed uh, a slightly lower resistance. Because of that, there's a potential drop when you connect and close a circuit. Okay, so now if you had E, which is the electromotive force, then you have to add minus IRL minus IR. So you already know. Then you have to solve these equations. If you have only one loop, it is very, very easy, right? So you go once around the loop and you should get zero because of Kirchhoff's voltage law, right? So go once around the loop. So in this case, when you go, let me go once around this loop. Okay, this is 2 volts, this is 4 volts, right? So let me start here and go 2, okay, plus 2 minus 4 minus I times R2 minus I times RL minus I times R1 equals 0. I go in one full loop around it. Okay, so plus 2 minus 4. Remember, you go from little bar to the upper bar, you say positive, right? So that's how it's done. Okay, so if you went the other way, you can also go the other way. See, in this case, he has put I in this way, right? He has put his eye, look at the direction of his eye. So he's going this way, right? So from A, he starts at point A to H minus 2, right? Minus 2 minus I times R1 minus I times RL minus R2 times I plus 4 equals 0. Okay, that's how you calculate. Now, otherwise, you just calculate the net voltage. If you have a single loop, it's a series, right? Net voltage is what? 4 minus 2 divided by the net resistance. Net resistance is 1 plus 5.3 plus 1.5, right? Therefore, you end up with a value. Okay, so or this is 5.5. Okay, so you end up with a value, right? So very, very simple. Power is V times I, V squared by R, I squared R. Okay, so you need to calculate. Power is the rate of work that's done. Power is dW by dt. Typically, it is leads to heat loss. What happens to the power in a circuit leads to heat loss. Resistors absorb and dissipate heat. Okay, that's why the insulator on top also tries to manage the heat. Okay, so that's what you do. Okay, so keep that in mind. I squared R, V square by R, V times I. Remember these three. So power loss and transmission, I square R, very long wire. You find out the SL by A, right? And you calculate the power transmission rates. Okay, so this is how these things are done. So keep this in mind. Okay, so we've kind of gone along here, right? So notice how I'm also getting you to look at how these problems are solved, but you should yourself start to solve some of these problems, because finally when it's time for the exam, I'm not, or nobody else is going to be sitting next to you. All right. So you have to be the person who really makes an effort, who really signs on. Okay. So now, having got you all started in this, I'm going to go to the next set of slides. Okay. So now, this is not an Independence Day, right? Independence Day has come and gone many months ago, but I will show you where to go. You can download Sushruta by going to your Play Store, Google Play app, right? Let me show you. Here is my Android phone. Okay, this is the Google Play app. I hope you can see it. Google Play app, right? So now when you go to Google Play, right, I type com.jnana.sushruta. Okay, com.jnanamarga.sushruta. Okay. When I type that, you get Sushruta for neat. Okay. When you get Sushruta for neat, you will hit the screen. Install. Okay. Once you install, you follow the instructions below and you register. You agree to the terms and conditions and you register. New to this app, register here. You click that and you register. Okay. Once you register, if you have problems, contact support at jnanamarga.in. Okay. Support at jnanamarga.in. If you have any issues, contact support at jnanamarga.in. Okay. Register. Once you register, then the next thing you do after you download and register, you go to what do you do? Then you use the app. You study from the app. You use the textbook, use the videos, and then you study from the app. Then after 2 weeks, you pay the cost of the app. Then you use it for whatever length of time you purchase. Okay. So electromotive force E times I, right? So now the potential drop along a circuit, right? VA equals VB plus IR, right? And I square R. It's the power, right? So what happens? There is a potential drop from point A to point B. There is a potential drop. What is the size of the potential drop? I times R. VB equals VA minus I times R, right? VA equals VB plus I times R, right? Either way. Now, the power is V times I or I square R. Okay? In transmission lines, power is dissipated due to resistance, right? So that's how you do this calculation, and you have these combination resistances. Typically, if you have combination resistances, you try to minimize as much as possible these combination resistors, combine them, the ones in series, add them up, the ones in parallel, do the 1 by R equals 1 by R1 plus 1 by R2, and then you combine those resistances. Then you solve using Kirchhoff's laws, which is voltage law, etc. We'll have as many equations and as many unknowns typically. Okay, so keep that in mind. Okay, so if you have series, just add them up. Okay, sigma Ri. If you have parallel, then you 1 by R equals 1 by R1 plus 1 by R2. Remember to know how to do this calculation. Okay, so and then R2 R3 by R2 plus R3 is the, if you have two resistors in parallel, R2 R3 by R2 plus R3, when you have R2 and R3 in parallel. Okay, so this is a very typical example. Right here you have this one and this one in parallel. R2 R3 divided by R2 plus R3. Take that and replace this one with the equivalent resistance. There's 2 and 3, therefore 2 times 3 by 2 plus 3, 6 by 5, replace with the equivalent resistance. Okay, so you can do quick calculation. So now here there's 2 and 6 by 5, right? In series, 2 plus 6 by 5 is what? 16 by 5, right? So he just replaced it by 16 by 5. Very simple, very quick. And then, so what is the current? 8 divided by 16 by 5. But then sometimes they will ask you to calculate the current in the 3 ohm resistance alone. Okay, now how do you calculate that, right? So now you calculated the current to be 2.5. So the current through this one is what? 2.5, right? So 2.5 times 6 by 5 is what? 3. 3 is the current through this one, right? No, the voltage across the R equivalent is what? 6 by 5 times 2.5, right? So now it is 3 volts. 3 volts is the voltage across the R equivalent. So now between this point and this point, what is the voltage drop? 3 volts. VAB, 3 volts, right? So now what is the current through this? 3 volts divided by 3 amps. 1 amp. What is the current through this? 3 volts divided by 2 amps divided by 2 ohms. 1.5 amps. So the 2.5 breaks 1 this way and 1.5 this way. Okay, so that's how you got to solve these problems. Okay, what is the voltage drop across this one, right? So voltage across drop across this one is 2.5 amps times 2, so it is 5 volts. Okay, so that's how you do these problems. So now here's another example. See, when he closes the switch, right? What happens when he closes the switch? When it's an open, you have these two as a series resistance, these two as a series resistance, and the combined in parallel. When he closes this, you end up with two parallel and then two more parallel. Okay, so you have to understand before the switch is closed what is happening, after the switch is closed what is happening. These are very, very simple things, but you must know how to do these problems. Sometimes if you are doing like JE or something like that, they won't ask very, very simple questions. They'll ask some more slightly tougher questions. They will introduce a diode, they will introduce a capacitor, they will introduce a switch, and then they will ask you, I rearrange this. Their aim is to confuse you, right? Because they have to find who's the better student in the case of JE, right? So NEET students also should learn how to deal with these things to the extent necessary. In CBSE students also learn to deal with these things. Okay, different board students should also learn. Okay, so here what is the power, right? What is the total power? I square R. What is the total resistance? Calculate the total resistance. I square R. V over R equivalent will give you the current. So I square R. Okay, and then you can then separate out the individual powers by calculating the individual I square R's. If you have two parallel branches, they will have different currents and they have different resistances, but they share the common voltage. Okay, so the best way in such cases is to do V square by R. You see, what is the V across R1? 240. What is the V across R2? 240. What is R1? Use that to calculate. All right, so use your brains. So in this case, using that, you can easily manage some of these questions. Okay, and be quicker about it. Okay, so building capability is a very good thing in terms of speed also. Learn to do things fast. You build adaptness. Okay, adaptness is important in particularly in NEET and JE also. They want students to not just be able to solve it in their own time, but solve it in reasonable time. Time is also a factor in all these NEET, JE kind of exams. So now we go to Kirchhoff's junction and loop law. Junction law is currents coming in equals currents going out. Sum of all the currents go in a junction, zero, right? Remember that sigma II equals 0 in every junction, any and every junction. Sigma Vi is equals 0 in any and every loop. So here, what is I1? I1 plus 4 equals 3 minus 2. Or I1 plus 4 minus 3 plus 2 equals 0. Right? Now, what about B? I2 plus 3 plus 1 minus 2 equals 0. Right? So if you say coming in is positive, going out is negative, you have to have a convention for that. Whatever it is, you have to have a consistent convention. Okay. So no, remember that if you take B, right, 3 is coming in. If you take A, 3 is going out. Remember that too, right? Depends on the particular junction. Voltage loop, once around the loop, should go to 0, right? So this is the critical aspects of loop law and current, right? So we already looked at this example, right? So these numericals, so you have two loops. When you have two loops, you will have two equations and two unknowns. Okay. See, in this case, you have two loops and therefore you will have two equations and two unknowns. Okay, so which are the two unknowns? The currents are the unknowns. So in this case, he creates I1 as the current he through this resistor, and I2 as the current through this resistor. So then he introduces I3 as, now using the junction rule, he sets I3 to equal I1 minus I2. So there are only two unknowns. Otherwise, you will have a lot of unknowns, a lot of variables, and then you will have to use Cramer's rules or something and become very, very difficult, right? So now he uses the junction rule to reduce the number of unknowns. So he has only two loops and two unknowns. Okay, the third unknown he solves using junction rule. Okay, so I3 is I1 minus I2. And he's look at the convention for I3. So now he's going to write the equation. So he starts out, let me start here, plus 12, right? Negative to positive plus, right? Minus I3 times 2, right? And I3 is I1 minus I2, right? So plus 12 minus 2 times I1 minus I2 minus 2 times I1 equals 0. Okay. Similarly, this one, minus 6 plus minus I2 times 2. And this one is going to be what? Plus I3 times 2. Plus I3 times 2. And I3 is I1 minus I2. So then you have two equations and two unknowns. You reduce it, use elimination, two equations and two unknowns. Okay. See, but in some cases, instead of KVL and KCL, KVL is what? Kirchhoff's current law. KVL is Kirchhoff's voltage law. Instead of KVL and KCL, you first reduce this. In this case, you see these two are in parallel, just combine them, are equivalent. 6 and 6 equivalent is 3. 1 by 6 plus 1 by 6 equals 1 by 3. So you replace it with the 3 ohm resistor, and then you have two equations and two unknowns. If there is some simplification, go for it. Equivalence resistance, do that, go for it. Okay, so then this one, look at this one. He's put one very interesting and complicated cube, right? So in such cases, if you just blindly do Kirchhoff's voltage current law, you will have problems. They are telling you that you must then use the symmetry, right? What is the symmetry here? What they are saying is that if the current here is 3I, it will break up equally. I. All the resistances are equal. Therefore, the currents will, because of symmetry, they will break equally. Now, these two also have symmetry, he's saying, right? So this one will go I2, this one will go I2. Okay. And because this one is I2, so you have to look at how these currents kind of add up. Okay. So because this breaks I from A, in D it is I going into D, and the other ones are all I by 2. Okay. So once you've done that, then so what can you say? Right? What can you say? So that is the symmetry here. So the loop, look at his loop, right? He's saying that because he has been able to use the symmetry, he is now using Kirchhoff's laws. Okay. So then if all these resistances are equal, so 3 3I, right, is the only these have resistances, right? So I times R plus I2 times R plus I times R equals V. So he has 2.5 R, 2.5 IR equals V. And therefore from that he calculates the I. Once he calculates the I, he calculates 3I. He is interested in the current going flowing to the battery, which is 3I. Okay. So notice how he was using symmetry. He is using symmetry very cleverly. He does not solve 10 equations and 10 unknowns. There are a lot of loops in that cube. Okay, it has 6 surfaces, means 6 loops. Then there's one outer loop, 7 loops. There's no 7 loops. You don't see 7 loops and 7 equals 7 unknowns. The symmetry is teaching him how to solve this problem. Tricky problems. JE is all about these kind of issues. Okay. So learn a little bit of these things also. Okay. So today I am going to stop a little bit early. Okay. So we are getting you guys ready for these kind of tests. Next class I will do a little bit with meter bridge and Wheatstone bridge. Okay. But the aim here for you is to learn to do these problems very, 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 very quickly. So I will end the next class with Wheatstone bridge and meter bridge before I go on to AC. Okay. Now, why are we going at such pace here? We're going at such pace here because this is just the revision session and we are getting students to get used to doing the problems. Lot of students, what is that? NEET exam is only 2 months away 3 months away, right? At least the CBSE exam is only 2 months away, right? That's why this is the time to be learning to do all these problems and do them well. Okay? So, um, in this question, we have to find the potential between C and D. Now, C and D is what? What is in between C and D? There is a capacitor. When you connect a capacitor between C and D, there is no current through the capacitor because this is a DC. When you first connect it, there will be a spike current. After that, there will be no current. Okay. So when there is no current, you then have to drop the capacitor, drop the 6 ohms, and then solve the two loops. There is two loops, right? There is this loop and then there is this loop. Okay. Now if you have only two loops and you know this voltage, right, that will be the voltage across this. Okay, so if you know the voltage across this, then you know the current across this. Okay, once you know the current across this, then you can use that to calculate the, what can you calculate? Current coming in, right? The current across this is, right, is also but we don't know the current across this, right? Current coming in here. So there is one current coming here, one current going there, right? But there is no current going there, right? So you have plus V, whatever that is, plus I times this 4 equals equals the net resistance. Equals 0, right? So you can then calculate the current in this, right? Now, if the current here is that, right, or the voltage drop here is known, then you can then look at the remaining parts, okay, and use that to solve for the currents, right? So, um, so you have two equations and two unknowns, two loops, therefore two equations and two unknowns. Let us say you choose the current in this to be I1, that is also this one, right? So if you say it is going up this way, it will be coming down that way, right? So if this is I1, this is also I1, right? So then this is I2. So now when you do one loop, right? So you then have, I2 minus I1 is this current, right? And therefore, you can calculate that current. And therefore, from that, you can then calculate the whole loop. Okay, so you have two equations and two unknowns. Okay, so you write the two equations, two loop equations, and two unknowns. Okay, then you solve for I1 and I3. Once you solve for I1 and I3, you will then know the voltage between C and A. Voltage between C and A is also the voltage between C and D. That's the point there. Okay, so not very straightforward, but it's not that difficult either. Okay, so here is a JEE mains question. In a large building, there are 15 bulbs of 40 watts, 5 bulbs of 100 watts, 5 fans of 80 watts, and one heater. Bijli ka bill, right? Bijli ka bill. How is your bijli ka bill? The voltage of the mains is 220 volts. The minimum capacity of the fuse of the building will be, right? V equals, so you add up all the power, right? 15 times 40, 600, 5 times 100, 500, 1100. So 5 times 80, 400, 1500, 1500 plus 1000, 2500. So 2500 is the power. 2500 equals V times I. So what is the I? Right? So 2500 by 220. The minimum capacity is what? So it has to be 2500 by 220, just the closest one above it, right? 2500 by 220 is what? 2500 by 250 is 10, right? So 2500 by 220 is probably 12. It's not 10, right? It is a little more than 10. So it's either 12 or 14. You have to do the calculation. 2500 by 220 and find the lowest number above that. Okay, which is in the 1, 2, 3, 4. Okay, so that's a very simple question. JEE means in the circuit shown, the current in the 1 ohm resistor is, so this is two equations and two unknowns. I1, I2, right? Then you calculate KVL, and then you solve. Tapak, get an answer. Okay, two equations, two unknowns, very quickly solve, very quickly get an answer, marks in the back. Don't get me wrong when I say such things, marks in the back. Your aim is to get a lot of marks. Okay, must be greedy for marks. I like students who want to learn the material and get all the marks that they can. Nothing wrong with it. Students' job is to get as many marks as you can. Okay, always get more marks. More marks is better for you, better for your parents, and better for me. Think I'm doing it for Srini. If you're not, always study hard for your parents and for your teacher. Every student and them yourself also, of course. But you do it better when you do it for others. Okay. So with that, I'm going to stop and I'll see you again next week. So all students, I am very proud of you. I am very expecting you to do well. I am hoping that you will all prepare hard, get yourself ready and solve a lot of problems, succeed. With that, I'm going to stop today. I'll see you again next week. Okay. So let's hope we keep making good progress and good pace.